Oh, yes, Anna?
Sir, may question lang po ako about sa problem set, kung tama yung pagkakaintindi ko.
Oh, sure. Go ahead.
Yung sa item number 3A,
Oh.
ipoprove po ba namin na yung y sub n ay convergent sa supremum? Yun po yung notation. Kasi di ba y
Yep.
sub n hindi naman siya sequence, parang isang value lang siya.
Yeah. Huh. Okay. So, the thing kasi ay yung yn ay isang value for each n. So, siguro to make it clearer, lagay ko rito ay for all n. So, okay. Kasi, di ba meron kang sequence, x1, x2, x3, and so on. Tapos, pwede kang makabuo ng isang panibagong sequence. Sequence naman siya ng mga yns. Now, ano yung sequence ng mga yns? Si y1, siya yung maximum ni x1. Si y2, siya yung maximum between x1 and x2. Si y3, maximum between x1, x2, and x3, and so on. So sa bawat isang n, meron kang isang value ng yn. Tapos pag kinolekta mo sila into a sequence, yun yung sequence ng mga yns, ang sabi ko rito ay magko-converge siya dun sa supremum ng xn kung si xn ay bounded. Is a bounded sequence. Medyo ano lang, I stick to the notation kasi ang notation natin sa nagko-converge si xn ay walang braces. So pag ganito yung sinulat natin, ibig sabihin yung sequence ng mga xn's ay nagko-converge kay x sub 0. So inadapt ko lang siya rito. Pero tama yung idea mo. Meron kang sequence sa mga yns, bawat isang yn ay isang value, pero pag tinignan mo siya sa sequence, y1, y2, y3, and so on, magko-converge yun sa supremum ng mga xn's.
Okay po, sir. Akala ko po kasi yung x sub n is isang ano lang siya, isang sequence, and then yung maximum ng elements ng x sub n, yung y sub n. Parang nalito lang pa ako sa part na yun. Yung pala maraming sequence yung x sub n.
Nag-iisang sequence lang si x sub n, pero marami siyang laman. So kaya lang pag nagbabago yung subscript nito, magbabago rin yung subscript nito. Right? So in the beginning, meron ka ng x1, x2. Nag-iisang sequence lang to, no? So hanggang ganyan. Tapos para makuha si y1, kukunin mo yung maximum nung unang term, unang isang term. Para makuha si y2, yung maximum nung unang dalawang terms, si y3 maximum ng unang tatlo, and so on. So makakabuo ka ng panibagong sequence. Alright? Tapos, ang claim ko dito sa 3A, magko-converge yung mga yns. Kanino siya magko-converge? Dun sa supremum ng xn. Alright?
Yes po, sir. Gets ka na po. Thank you.
Okay, yeah. Medyo inano ko lang yung, yung terminologies. Alright, other questions about the problem set?
Yan lang po, sir. Okay na po.
Okay, alright, you're welcome. So for the benefit of those who are watching the recording, so just a reminder, you need to submit 4 problems on May 13. That's going to be on, tama ba, Friday? Oh. Yeah, that's going to be on Friday, right before midnight. So that gives you 4 working days, including today. So kailangan nyo maka 1 item per day. So kung gahol na kayo sa oras today, try to answer the essay part. I think that's easy. So anyway, number 1 is required, yung essay part. Tapos yung objective part is also required. Tinawag ko siyang objective part, pero ngayon para may partial credit, justified true or false yung unang tatlong problems. Tapos yung parts D and E ay solving for specific values. So you can send your here you will send your solutions or answers as a PDF file na lang din. So there's a separate bin per numbered item. Hindi ko na ginawa yung last time para para pwede kayo maka-partial points. Yeah, so that means there is a reasoning needed for A, B, and C, and then there would be solutions needed for D and E. Pero okay lang na minimal solution for D and E Gusto ko lang makakita ng solution para mabigyan ko kayo ng partial credit in case na medyo sumabit ng konti yung reasoning o yung solution, ano? And then also just to make sure na nag-try kayong magsagot and hindi nyo lang hinulaan kung ano yung answer sa D&D. And then you need to answer 2 proving questions, pero hindi pwedeng parehong odd nor parehong even. So ibig sabihin, you choose one between 3 and 5. Problems 3 and 5 are about sequences, and then problems 4 and 6 are about functions. So kaya hindi pwedeng parehas na odd or parehas na even para yung sasagutan niya isang about sequence at saka isa tungkol sa functions. All right? So good luck on the problem set. It's due on on Friday. And then medyo distracted nga kagabi, so hindi ko nagalaw yung homework number 5. So natapos ko yung homework number 4 for those who submitted in Canvas. I think madaling araw ng May 9 kasi pinlano kong pumila ng maaga sa pagboto. So halos madaling araw hindi na ako natulog ng mahaba para kasi pag natulog ako ng mahaba, tanghali na ako magigising and so on. So kaya na-checkan ko siya. Kahapon di ko nagawa yung mga trabaho ko. So but expect within the week I'll have homework number 5 graded. Okay? So today we'll start a brand new module or a brand new unit in the course. This is the second to the last, and it will tackle the second main pillar of calculus. Ito yung konsepto ng derivatives. So, and then we have gone a long way. So in the first unit, we talk about the real number system or the real number set or the set of real numbers as a complete ordered field. And we realize na ito pala, yung pagiging complete ordered field niya ang nagbigay sa atin ng kakayanan para makapag-discuss ng isang rigorous calculus course because most of the properties that we are relying on, like limit points and so on, they all require the set under consideration to be a complete ordered field because without it, without completeness, for instance, we cannot talk about convergence of sequences, least upper bounds, and so on. So medyo makukulangan tayo kung wala yung konsepto ng completeness. And then after that, we look at the first pillar of calculus, yung limits, all right? And we look at 2 versions, limit ng sequences, which is basically more restrictive kasi ito lang yung mga functions ng domain ay natural numbers. Pero during the third unit, we generalize the notion of limits papunta na sa limits ng mga functions ng domain niya ay arbitrary set na ng real numbers. And along the way, we're able to expand the concept of limits that we encountered in Math 36. Na ngayon, medyo loose yung restrictions natin doon sa mga numbers kung saan natin ine-evaluate yung limit. Instead of requiring that the function is defined in some open interval containing the number being considered, naibaba natin yon into just considering yung mga limit points. Okay? Hindi na kailangan siya ay nasa isang open interval. So pwedeng half interval lamang kung saan defined yung function all throughout. Okay? And tapos pinagtahi natin yung dalawang konsepto na yun. How does the concept of a limit of a function intertwine with the concept of the limit of a function? And that relationship gave us sequential criteria not only for limits but also for continuity and uniform continuity as well. Okay? So ngayon, medyo mag-move on na tayo at titingnan natin ano pa yung yung pangalawang aspeto ng calculus. Actually, the 2 remaining ones, differentiation and integration, are basically hinged on the concept of the limit of a function. Right? If you remember, we defined the derivative as the limit of a difference quotient. We shall also see that later. While integrals, limit lamang siya ng Riemann sum. So basically, kaya maiksi itong dalawang natitirang units kasi nga halos lahat ng mga kailangan nating properties, basic properties at least, ay nai-inherit mula sa properties ng limits. So we will be looking at just results that are more profound and will have more consequences kaysa dun sa mga basic differentiation theorems, basic integration theorems, and so on. After all, itong dalawang natitirang units ay walang masyadong pinagkaiba dun sa natutunan natin from Math 36. Hindi katulad ng limits na medyo may malaking chunk ang bago o significantly new mula dun sa natutunan natin sa Math 36. Ngayon, medyo papalalimin lang natin yung diniscuss nyo sa Math 36. And true enough, this module is just 10 pages long. So I target to finish it on Thursday. And it also just covers two sections, the derivative and basic properties, plus the mean value theorem. So let's dive into the module itself. Unahin natin, ano yung konsepto ng derivative? Well, definition 4.1 is nothing new. This is not a shocker. This is what we learned from Math 36, exactly what we learned from Math 36. Wala nang pinagkaiba, right? So una, dapat yung function f ay defined sa isang subset ni A, all right? And it will be differentiable at the point at the domain. So unang takeaway rito, we can only talk about differentiability at the point in the domain. Unlike limits, sa limits, hindi kailangan na defined yung isang function kung saan mo siya i-evaluatean ng limit. Alright? Sabi nga natin sa Math 36 definition, meron pang caveat na let f be defined in some open interval containing a except possibly at a. So we are putting the possibility of the limit existing even if the function value doesn't exist. Pero sa konsepto ng derivatives, dapat nag-exist yung function value. Because a point where we want to test differentiability ay dapat miyembro ng domain. Okay? And how will that happen, or when can we conclude differentiability? We can say so if and only if f is defined in some open interval, so same preamble as what you had in Math 36, containing a, and this limit exists. Okay, so basically this is just the limit of the difference quotient, f of x minus f of a all over x minus a. And if you remember from elementary calculus, yung derivative at the number a is just the instantaneous rate of change. Because for instance, if you consider your function f, say this one, and this is your number a in the domain, okay? So, bakit kailangan natin na merong open interval na nagko-contain kay a kung saan na-test natin yung yung differentiability? Bakit hindi lang kailangan limit point? Bakit kailangan nandun siya sa set itself? Or bakit kailangan define siya in some open interval? The reason there is we can only calculate change if we are sure that there is always a point in the domain that is extremely close to the number a. Because again, derivatives measure the instantaneous rate of change. Ano yung change kapag ka super lalapit na nung changes in the x values. So kapag ka si A ay hindi defined sa isang open interval containing or walang open interval kung saan siya defined, ibig sabihin butas-butas yung graph. So hindi natin makukuha yung instantaneous change o yung change at a particular moment in time around A. Kasi wala tayong value to where it will be compared to, right? So kaya kailangan talaga merong open interval na kung saan defined palagi sa buong interval na yon yung function A. Because the idea is yung rate of change, halimbawa meron ka ritong A plus H or A minus H, halimbawa. Oops. Meron kang A minus H, kunin mo yung function value, para makita yung relative change between the function values with respect to the x values, kukunin natin yung difference between the function values divided by the change in the x values. And basically, that is the slope of the secant line or the line passing through points in the curve. So yun yung nagiging measure natin ng relative change. Now, the derivative is instantaneous. Ibig sabihin, dapat napakaliit ni h. Napakaliit nung change doon sa x value. So you can think of it as a limiting process. Pero itong second point na to ay palapit ng palapit doon sa number a or doon sa function value at the number a. And the limit of that secant line is what we call the tangent line. Okay? Tapos makikita nyo, it's apparent in the definition that we want the increment to be very, very small. So we want the second point na pinapang-construct natin ng secant line to be arbitrarily close to the point A, comma, f of A. Kaya siya instantaneous. Kasi sa isang pikit mata, doon natin mini-measure yung change in the function values, in contrast dun sa konsepto ng average change or average rate of change. Okay? Now, that is encapsulated in this limit definition. There are two versions. You can choose which one to use according to your convenience. But I think more often I'll use this one rather than this one. Pero they are equivalent, so you can just use any one of them. Okay? Now, if this limit exists, then we say that f prime of A is the derivative of f at A, and we say that f is differentiable at the number A. Okay. Moreover, if there is a set or an interval at which the derivative is always defined, okay, so pwede natin sabihin na si f ay differentiable dun sa set na yon. And we write f is an element of curly d of I. So yung curly d of I, you can think of it as the set of all differentiable functions on the set I. So, or we can read it simply as f is a differentiable function on the set I. Okay. So as I mentioned, exactong-exacto to, Math 36 version. So that means all of the things that we learn from there can be carried over, and I will allow you to use them. All right? Siguro, umpisahan ko lang. Lagyan ko lang ng konting konteksto bago ko i-formally proclaim na pwede niyong gamitin without proof yung mga basic properties na galing sa Math 36. All right? So tingnan muna natin yung dalawang examples. Example 4.1, this tells us, or this gives us a formula for the derivative of the power function for any natural number n. Okay? But to establish it, gamitin natin yung definition. Okay? So sabi nung example 4.1, kapag kasi f of x ay x to the power n, and is a natural number, then the derivative is either equal to n times a to the n minus 1, when n is not equal to 1, but it will be 0 kapag kasi n ay equal kay 1. Tama ba? No, that's wrong. This should be 1. Sorry about that. Kokorek ko ulit siya mamaya. Okay. So ang derivative ng f prime of A ay equal kay 1 kapag kasi n ay equal kay 1. All right? So let's take a look at the proof. Actually, this is pretty straightforward. Kailangan lang ng konting algebra skills. So una, first case, when n is not equal to 1, and then ano yung mangyayari? Well, just use the definition over here. F prime of A is equal to this difference quotient. And then, let me see. Hindi siya mag-0, Ana, kasi nagdi-differentiate ako with respect to x. Tama ba? So kapag kasi n ay 1, ibig sabihin ito ay magiging f of x equals x to the first. So ang derivative ni x to the first ay equal kay 1. Function value niya ay laging 1. Okay. Siguro yun din yung iniisip ko kanina kaya nakalimutan ko siyang palitan. Pero nakita ko dun sa proof at tama naman yun nasa proof. Okay? Is that good? So yung second case ay case para sa linear function x, identity function x. All right. So now let's see. Okay. So ginamit ko yung definition ng nandun sa definition, yung limit definition ng derivative. And then I'll simply plug into that expression f of x, which is x to the power n, minus f of a, but f of a is a to the power n, all over x minus a as x approaches a. And then I'll use a special factoring technique. So I can factor x to the power n minus a to the power n with x minus a as one of its factor. Or you can do long division and you will get this guy, which is a polynomial with how many terms? It will have n terms, right? So mula kay x to the power n minus 1, x to the power n minus 2, hanggang kay x to the power 1, meron tayong n minus 1 terms. Tapos yung constant term, siya yung pang n na terms. But anyway, regardless of the number of terms, this guy is only a polynomial in X. And we know that polynomials are continuous everywhere. So it is continuous at the number A or at the arbitrary number A. So para makuha yung limit ng isang polynomial, pwede tayo mag-plug in. Kasi continuous siya, so ang function value ay equal dun sa limit. So plug in X equals A in here. So ito ay maging A to the power n minus 1. There you go. This is A to the power n minus 2 times A. So we'll get A to the power n minus 1 again. And actually, you can do this over and over again hanggang pumunta ko dun sa constant term. A to the power n minus 1 pa rin yung function value. So the limit is a bunch of A to the power n minus 1 added to each other. But in particular, ilan yung pinag-a-add natin na A to the power n minus 1? Meron tayong n na such addends. Okay, so since there are n addends, the sum here will be n times A to the power n minus 1 as we claimed in the formula. So indeed, the derivative of f at A when n is equal to, when n is not equal to 1 is equal to n times A to the power n minus 1. Okay? Medyo kailangan ko lang ihiwalay yung case na kapag ka si n ay equal kay 1. Kasi kapag ka si n ay equal kay 1, mukhang papasok pa rin siya rito kasi magiging ano lang siya, 1 times A to the 0. So this will just be equal to 1. All right? However, there is a little bit of a technical aspect to it. Kasi kapag ka si A ay 0, magkakaroon tayo ng 0 to the 0 and it is undefined, right? Tama ba? Undefined ba ang tamang term? Sige, double check ko nga. 0 to the 0. Kasi I see some textbooks defining 0 to the 0 as 1. Actually, yung ilang calculators ang 0 to the power 0 nga ay 1. Mm-hmm. Yeah. But I guess, and I have to agree, na ang 0 to the 0 can be defined as being equal to 1. Yung 0 to the 0, siya yung indeterminate form siya kapag ka yung base ay nag-approach ng 0, tapos yung exponent nag-approach ng 0. Yun yung nasa L'Hopital's rule, kung bakit siya indeterminate form. Pero kung meron kang eksaktong 0, i-erase mo siya sa 0, some books will tell us by definition or by convention that is equal to 1. Though hindi mo siya ma-imagine as multiplying 0 to itself 0 times, all right? Kasi nga, i-multiply mo daw si 0 to itself 0 times. So, ibig sabihin, wala ka dapat makukuha na product, or at least the product would be equal to 0. That's why by convention we say that is equal to 1. But to make our example independent of the convention for 0 to the power 0, so ang gagawin ko na lang ay, ang ginawa ko na lang, inhiwalay ko na lang yung case na n equals 1. Para hindi tayo magka-problema, kapag kasi n ay 1, magkakaroon ako ng posibleng 0 to the 0 times 1 doon. Kaya hiniwalay ko yung case na n equals 1. Because if n is equal to 1, the proof is even simpler. So ito yung definition using limits, all right? Plug in f of x, that's x to the power 1 or simply x. F of and then this is f of a, which will be a, right? Plug in ko siya sa x, makukuha ko ay a. Oh, I'm gonna have x minus a. Bakit mali? This should be x minus a over x minus a, all right? And then that will be limit of 1. Kasi sa limits, pwedeng mag-simplify ka muna. Tapos saka mo evaluate yung limits. I'm gonna have x minus a all over x minus a. That's equal to 1. Limit of the constant 1 as x approaches a is still equal to 1. Okay? So, yeah, so that proves yung limit formula natin for powers, okay? And then remark 4.1 is telling us that we can generalize this notion for every, or this formula for any real number n. Though there are some caveats to it, especially kapag ka si n ay equal kay -1. Kasi kapag ka meron kang x to the -1, ang derivative niya ay ln ng absolute value of x. So magkakaroon ka lang ng additional layer. But for other numbers, except -1, nag-hold yung formula na yon. Even if it's an irrational number, if it's a rational number, then you can use the power rule. Yun yung tawag natin sa Math 36. So with the power rule known, so pwede nyo na itong gamitin without proof in any exercises, homework, or problem set. Siguro isama na rin natin sa mga pwede nyo gamitin yung mga basic derivative formulas for trigonometric, inverse trigonometric, hyperbolic, inverse hyperbolic, exponential, and logarithmic functions. So yung mga formulas na natutunan nyo para sa derivatives nila, pwede nyo nang gamitin sa Math 155 without any proofs. So wag nyo nang gamitin yung definition to prove them. I will just allow you to quote Math 36 materials from there. Okay? Now let's look at another example. Ito naman yung absolute value of x, and we were tasked here to show that f is not differentiable at 0. Okay, so since we want to show that f is not differentiable at 0, kailangan ipakita natin yung limit na nagde-define dun sa f prime of 0 to be non-existent. Okay, so kaya mula sa definition, kailangan daw nating tingnan ano yung nangyayari dito. The goal is to show that this does not exist. But if we plug in the information that we have, f of x is just absolute value of x, f of 0 is 0, so that's fine, divided by x. So ito yung gusto nating i-analyze na limit. Essentially, we want to show that this limit doesn't exist. So to do that, I'll take advantage no natutunan natin na sequential criterion. So ang gagawin ko, maghahanap ako ng dalawang sequences na nanggagaling sa set of real numbers na nagko-converge kay 0, pero yung sequence of the function values they generate dapat magko-converge sa magkaibang numbers. Okay? And what I thought of is, sige nga, i-define ko yung xn to be sequenced sa mga -1/n's. Obviously, this will converge to 0. Okay, dun sa limit point, kung saan natin tinetest yung differentiability. On the other hand, I can define the sequence yn to be the sequence consisting of 1/n's. Tapos nagko-converge pa rin yan kay 0. Now, the good thing is, pag kinuha ko yung limit ng function values ng mga xn's under this map, under the absolute value of x over x. So, ito yan, kukumpitin ko yan. Tapos alam ko yung -1/n, lagi yung negative, right? Ang absolute value ng kahit anong negative ay yung negative niya. So it will be the positive version of it. So this guy will be 1/n. Tapos yung denominator ay xn, so it's going to be -1/n. So yung quotient ay -1. So yung sequence ng mga function values ng mga xn will consist of only one constant, and that is equal to -1. Dahil constant yon, yung sequence ng mga function values magko-converge to -1. All right. Now I'm hoping na yung sequence ng function values ng mgayn's naman ay hindi mag-converge sa -1. And true enough, the 1/n's are all positive. Absolute value of a positive number is itself. So the top is 1/n divided by 1/n. Yun yung yn natin. This simplifies to 1. The sequence of function values of the yn is a constant sequence consisting of only ones, and thus it will converge to 1. And now we have two sequences of function values whose pre-images both converge to the limit point 0 na kino-consider natin. So ibig sabihin, magkaiba yung limit ng dalawang sequence of function values. We can say that the limit of the function does not exist. But we mentioned that this is exactly how the derivative would have been defined for x equals 0 or for a equals 0. Dahil hindi nag-exist yung limit, ibig sabihin hindi mag-exist yung derivative. So we conclude that f is not differentiable at 0. Okay? Any question with the two proofs that we have seen? Okay. So kung wala, now one observation that we can make about from these two examples are as follows. Yung example 1, polynomial yan, x to the power n. In particular, it's a monomial, ano? And we know that polynomials are continuous everywhere. So a continuous function seems to be always differentiable, as we have seen here. Okay, but our hopes were shattered by example 4.2. Kasi si absolute value of x, alam ko continuous yan. Kaya kong i-drawing yung graph niyan without lifting my pen. All right? So, continuous. Dahil continuous siya, pero meron palang points kung saan siya hindi differentiable. So, it appears that continuity is not a guarantee for differentiability. In fact, there are continuous functions such as the absolute value function that are not continuous, that are not differentiable. All right? So, yun yung relationship between the two. However, if you have a differentiable function, we will show later that it is necessarily continuous. Okay? So, do you remember any condition para sa differentiability? Kasi kung yung continuity ng Math36, kinaracterize natin as mga functions na ang graph nila ay kaya kong i-draw without lifting my pen. May tanda ka ba na condition na similar to that para sa differentiability?
Wala po akong maalala, sir.
Alright. Sorry, Ana, mapuput on the spot ka talaga ngayon, ano? Kasi ikaw lang yung umattend. Pero anyway, yeah. Siguro narinig mo na to, nakalimutan mo lang, yung pagiging smooth ng graph. So dapat daw smooth yung graph para maging continuous yung function. Diba, yung mga polynomials. Yung graphs nila parang ganyan. So there's some sort of smoothness to it. Tapos ano pa ba? Sines and cosines. Hindi nga lang masyadong smooth yung curve ko. Pero yan, medyo aside from being continuous, smooth dapat yung pagkakadrawing. Hindi katulad ng absolute value function na V-shaped and there is sort of a non-smoothness here. There is a sudden turn at the vertex. So, yun yung parang clue na hindi siya differentiable. Also, functions that have cusps. So, kapag yung function mo, ganyan yung itsura, meron ka ritong cusp or sudden turn, na medyo nagtatry siya maging smooth, pero makikita mo may sudden behavior. Halimbawa, ito. Yan. Meron siyang cusp dito sa gitna. Okay? So, ibig sabihin, hindi pa rin yun differentiable kasi merong sudden unexpected surge or behavior na nangyari. So, hindi naging smooth yung transition from one function value to another. Okay. Pero kaya pa rin nating i-drawing yung graph niya without lifting our pen because we will prove that kung yung function mo ay differentiable, automatic siya ay continuous. And the converse of this theorem will provide us a criterion for non-differentiability. Kasi differentiability, so ang sinasabi nito, if f is differentiable at the number a, then it is continuous at the number a. So yung contrapositive niya, converse ba sinabi ko kanina? Dapat yung contrapositive niya, yun yung true. Anong contrapositive nito? If f is not continuous, then f is not differentiable. So basically, yun yung pwede nating makuha or interpretation for Theorem 4.1. But it is quite easier to prove it to prove the statement that was used in Theorem 4.1. Now, pagka siya ay differentiable, dapat automatic siya ay continuous. So, pwede na nating isama or with the contrapositive of Theorem 4.1, pwede na nating isama dun sa ating graphical test para sa differentiability na dapat siya ay continuous muna. Kasi walang discontinuous function ang nagiging differentiable. Right? So let's prove it. So in the proof, our assumption is that f is differentiable. So kung si f ay differentiable, ibig sabihin nag-exist itong limit na ito. Okay? So ito yung nanggaling, or si g ay differentiable, so nanggaling sa definition, nag-exist itong derivative na to. So the challenge is for us to make use of the existence of this limit para mapakita na ang limit ni g of x as x approaches a ay hindi lamang nag-exist pero equal kay g of a. Kasi nga gusto nating ipakita yung continuity ni g at the number a. Okay? So yun yung goal dito. And siguro nakikita nyo na to, isa tong major usual challenge sa mga analysis proofs. Dapat creative tayo mag-isip. We need to be able to either construct one thing or rewrite a certain expression in a very convenient and usable or practical form for us. In that particular manner, I want to make use of this guy. Okay? Para mapakita na ang limit ng g of x ay equal kay g of a. Well, that's our goal. So gusto ko ipakita ng limit ni g of x as x approaches a ay equal kay g of a. Alright? So one way to show this is, okay, remember si g of a ay constant lamang, so pwede ko itong isulat sa loob ng limit. So pwede ko itong tingnan as limit ng g of a as x approaches a. Tapos transpose ko sa kabila yun, so magkakaroon ako ng limit ng g of x minus limit ng g of a as x approaches a. Meron tayong limit algebraic theorems na pag meron kang difference ng dalawang limits, equal lang yun sa limit ng difference nung dalawang function values. Okay? So, ibig sabihin, para ma-investigate yung nangyayari sa limit of g of x, pwede ko palang tingnan kung ano yung nangyayari sa limit ng g of x minus g of a. And why do I know that that might be fruitful? Kasi nga, tingnan mo yun sa g prime. Yung g prime, ang numerator niya ay g of x minus g of a. And essentially, sabi natin, yung numerator, yan yung gusto kong imbestigahan kung ano yung nangyayari sa kanya. Okay? So medyo magkamukha sila. So sige na nga, tingnan ko ano yung mangyayari sa limit ng g of x minus g of a. Now, I want to take advantage of the assumption na narito. Alam ko na ito nag-exist at equal kay g prime of a. So, kamukha siya nito except for the denominator x minus a. So what I'll do is to just divide this guy by x minus a, tapos bawiin yung pinang-divide ko by a multiplier so that everything will cancel out back into g of x minus g of a. And that's what happened in the middle line over here. Tapos dito, I am not violating anything because you might complain, oh sir, parang may mali. Bakit ka nag-divide ng x minus a? Hindi ba magzi-zero yung x minus a? Well, that might be correct kung si x ay equal kay a. Pero remember, we are evaluating the limit. Everything here happens under the auspices of the limit symbol. Dahil may limit dyan, alam ko na si x ay hindi eksaktong equal kay a. Because the limits, ang business lang natin ay about numbers that are very, very close to a. So yung x minus a, hindi talaga yan magzi-zero. Kasi nga si x palapit pa lang ng palapit kay a. Hindi siya eksaktong si a. So this guy might be infinitesimal, but the thing is, we can divide by any number, however small. Basta wag siyang magiging equal kay 0. So division by x minus a is fine, okay? And the reason why I want to do that is, alam ko nag-exist yung limit nito. Ang limit nito ay g prime of a. Alam ko ang x minus a ay continuous kasi polynomial yan. So kung polynomial yan, continuous yan, so may limit yan. Alright? So I have the limit of the product where each factor has a limit. Sabi ng algebraic limit theorems, yung limit ng product ay product lamang ng limits. So limit of the product is equal to the product of the limits, namely, yung limit nito ay g prime of a by definition, and limit ng x minus a as x approaches a by the algebraic limit theorems, or by continuity actually. Plug in ka lang ng a minus a ay equal kay 0. So essentially the limit of this guy is equal to 0. Pero 0 yan. Ano ang sabi natin kanina? Yung limit ng g of x minus g of a ay equal lamang sa limit ng g of x minus limit ng g of a. Pero ang limit ni g of a ay equal lamang kay g of a. So we know now that the limit of g of x as x approaches a minus the constant g of a ay equal kay 0. Therefore, the limit of g of x as x approaches a must be equal to g of a. But what does this equality means? Ang limit ni g of x as x approaches a doesn't just exist, but it is equal to the function value g of a. And from there, we can say that g is continuous. End of proof. All right. Questions with that? Okay, great. Everything's making sense. Okay. Now, tingnan natin yung mga basic formulas na pwede nyo rin gamitin. Okay? So, ito yung mga nakita nyo na kung ano yung proof na ginamit nyo sa Math 36, yung pa rin yung mga proofs na gagamitin natin sa Math 155. Kasi nga, wala namang pinagkaiba yung definition ng limits. Pero meron palang isang ibang paraan. Kung gusto yung level up, Math 155 version yung proof, pwede kayong gumamit ng sequential criterion. Katulad nung ginamit ko pagpapakita ng derivative na hindi nag-exist yung derivative ng absolute value of x. Kasi yung Math 36 approach dito ay derivative from the left saka derivative from the right, which is essentially the limit from the left and the limit from the right. Unfortunately, wala tayong konsepto ng derivative from the left and derivative from the right dito. So, pero pwede mong pa rin itago yung proof, pwede mong kunin yung limit from the left at limit from the right. Pero meron yung technicality, right? Bago mag-hold, yung mag-exist lamang yung limit, kung equal yung limit from the left at limit from the right, kailangan muna si number x sub 0 o si number a ay parehas isang left limit point at saka isang right limit point. So just to escape that technicality, gumamit na lang ako ng sequential criterion. Mas straightforward. Okay? Anyway, hindi naman ako nahirapan maghanap ng sequence. Kailangan ko lang makahanap ng sequence ng mga negative numbers na mag-approach kay 0 at sequence ng positive numbers na magko-converge kay 0. Kasi alam ko na yung function value nung nasa kaliwa ay negative palagi. Function value nung nasa right-hand side ay laging positive. Okay, now going back to Theorem 4.2, most of them, or actually I think all of them, will just entail a nice representation for the expression inside the limit. Okay, katulad yung sa product rule. Okay, yung sa part C. Hindi ganun kasimple yung pagdi-differentiate ng product. Hindi katulad ng pagdi-differentiate ng sum saka scalar multiple. Na ang derivative lang ng sum ay sum ng derivatives. Ang derivative ng scalar multiple ay scalar multiple lang ng function value. Yung derivative ng product will make use of the product rule, and the derivative of the quotient will make use of your low d high minus high d low over low squared. Okay? So paano sila ipoprove? Madali yung A and B, so try to think about it. Okay? Pero kung nakalimutan, silipin si Leitold o yung notes ng Math 36, makikita niyo yan doon. Tingnan na lang natin yung clever idea for the proof of part C and D, or the product rule. Sa product rule, usually ganito yung simula. Mag-start ka lagi dun sa limit definition ng derivative. Medyo tinanggal niya na dito yung limit kasi kayo na daw yung maglalagay nung limit. Pinakita niya lang ano dapat yung nice way of writing the limit that you will encounter in the difference quotient. So ito yung difference quotient. Yan yung supposedly nasa loob ng limit as x approaches a para makuha yung f g prime of a. Alright? Kaya lang, yung expression na yan, pag in-expand mo, ito yung magiging itsura. Now, kailangan natin ng isang magandang paraan or isang magandang pagkakasulat ng expression na to para yung ma-evaluate nating limit ay mag-involve ng f prime at saka ng g prime. Kasi yun yung crucial dito sa power rule, okay? Now, it turns out that one way to do it is to add and subtract f of x times g of a. Oops. Ito daw yung trick. Diba nag-add tayo ng isang number that is equal to 0. Okay? In this particular case, itong dalawa yung aking ipag-add. Okay? Now, bakit maganda yung i-add? Kasi when I add and subtract these two quantities, alright, magkakaroon ako ng dalawang grouping ng mga terms. Yung unang group ay ito, yung pangalawang group ay ito. Ang kagandahan dun sa unang group, pwede ako mag-factor ng f of x. Okay, factor out si f of x, matitira na lang ito sa numerator, si denominator x minus a pa rin. Yung sa second group, the common factor is g of a, so I can factor out the g of a, and then this is what will remain as the other factor. Tapos medyo masaya to. Bakit masaya to? Kasi pwede ko na silang kunan ng limit. So pag kinuha ko yun ng limit, so kukunin ko yung limit nito, alam ko ang limit nito ay yung derivative. Pero ano yung limit nito as x approaches a? Well, we know that f and g are both differentiable. Okay? So ibig sabihin, kung si f at saka si g ay parehas differentiable, ibig sabihin silang dalawa ay parehas continuous, right? By Theorem 4.1, differentiability implies continuity. So dahil si f at saka si g ay continuous, lagi silang may limit at x equals a, or as x approaches a. Dahil may limit yan, so may limit ito, tapos ito ay nag-exist. Yung limit nito, may limit din yan kasi alam natin si g ay differentiable. And this is nothing more but g prime. So, ibig sabihin ito, may limit yan. Tapos si g of a ay constant. So, definitely may limit yan as x approaches a. Kasi yung limit nito ay nag-exist din kasi si f ay differentiable by assumption. And actually, the derivative is just f prime of a. Now, dahil bawat isang factor na nandito sa sum ay may limit. So, pwede nating hati-hatiin yung limits isa-isa. So, ibig sabihin, ang limit nito ay equal sa limit ng f of x as x approaches a. So, that's gonna be f of a times the limit of this guy, the difference quotient, but that is g prime of a, plus limit ng g of a, but g of a is just a constant, so its limit is just itself, times limit nito as x approaches a, it's just f prime of a. Okay, so that's the end of proof. Okay, formalize nyo na lang. Pero the crux of the proof is really here. Yung pagkaka-expand nung simplified expression. Alright? Paano natin siya pinahaba para makuha yung necessary factors para mapalabas yung g prime at saka yung f prime. And it's a usual theme, ano? Hopefully na-imbibe nyo na madalas yung mga analysis proofs meron ito. The same principle or the same routine can be applied to derive or to deduce the quotient rule. Yun nga lang dito, anong ginawa niya? Ito naman yung in-add and subtract niya. Okay, tapos nag-multiply pa ba? Yeah, I think that's straightforward. Tapos rearrangement lang ng mga terms. So you are given here the hint. Makikita nyo, pag kinuha mo yung limit nito, saka limit nito, makukuha mo yun nandun sa formula. But what I want you guys to appreciate is how we got from this until here. Kasi ito yung mga tools na madalas natin ginagamit. So mas maganda na tayo ay nagiging mas familiar na sa mga ganung galawan, sa mga proofs in analysis. Okay? Now, again, you can now use those basic properties or basic formulas for the derivatives. May isa pa palang basic property tayong ginagamit, no? And that's what we call the chain rule. Pero sige, prove natin yung chain rule. Ano yung requirements para sa chain rule? Dapat si function f saka si function g ay may domain A and B respectively. Pero on top of that, f bracket A must be a subset of B. Ibig sabihin, gusto natin lahat ng function values under A ay nasa domain ni B. Kasi remember, sa G circle F, in-evaluate natin to as G of f of x. So dapat yung function value under F ay nasa loob ng domain ni function G para maging well-defined yung G circle F. Okay? Tapos if we throw in the following additional assumptions, namely f is differentiable at number A and G is differentiable at f of A, then we can say that G circle F is differentiable at A with the following formula. So to establish the theorem, we just need to show that this limit exists. All right? Kasi gusto natin ipakita differentiable si G circle F kay A. So dahil gusto natin ipakita siya ay differentiable, kailangan natin ipakita na yung limit na to ay nag-exist. Okay. But what are our assumptions? F is differentiable at A and G is differentiable at f of A. And then if we look at this, yung target natin, mapakita na nag-exist yung limit na to. Okay? Nag-involve siya ng G of something or ng G circle F. So that's why it's very much worthwhile to look at what happens to G, the function G first, bago pupunta kay function F. Now, ano yung alam natin kay function G? Alam ko siya ay differentiable kay f of A by assumption. Okay? So dahil siya ay differentiable at f of A, i-apply ko lamang yung definition. So parang ito yung f is differentiable at A. Parang yung sinabi natin kanina. So, pero ngayon pinalitan ko, yung domain element ay si f of A. So, ang kukunin ko ay limit as the variable approaches f of A. Hindi lang basta x approaches A, kasi ang variable ngayon o ang domain element ni G ay si f of A. So, siya yung pupuntahan ng variable under the function G. Just to avoid confusion, with the variable x used here, okay, gumamit ako ng variable y para dun sa pag-a-analyze ng derivative ni G. Okay? So kaya g of y minus g of f of a yan all over y minus f of a. Okay. So, yeah. So, yun yung meron tayo so far. Now, gusto kong malaman ano yung relationship between this and this guy. Yun yung gusto kong i-compare. And apparently to do that, I need to go through an function v. Okay. Ano to si v, si function g? Sorry, si function v. Dinefine ko lang to by dropping the limit symbol here and transposing this guy. Okay? So yun yung kinuha ko. So I know that in the long run, v will go to 0. And not in the long run, but as y approaches f of a, papunta to sa 0. Kasi pag kinuha ko yung limit yan, as y approaches f of a, so ito, kukunin ko rin yung limit nito, minus, but this guy, ang limit niya ay equal kay g prime of f of a. So ang limit nito, as y approaches f of a, ay g prime of a, minus g prime of a, I know that v approaches 0. So yun yung observation natin about v. But one thing about this is that v is not defined for all y's. Kasi kapag si y ay naging equal kay f of a, ito ay magiging eksaktong 0. So si function v ay magiging undefined even though v has a limit as y approaches f of a. And I want v to be a continuous function. So I want a continuous version of it. Now, ito yung ginagawa natin sa Math36 dati na nire-redefine natin yung isang function na may tinatawag na removable discontinuity para siya ay maging continuous. So in that spirit, we are defining a new function function d. D yung tinawag ko dyan kasi siya yung parang differential. Makikita natin later kung bakit siya yung parang differential. Pero siya ay equal kay v of y. Kung si y ay hindi equal kay f of a, kasi equal siya dun sa limit which is equal to 0 kapag ka naman si y ay equal kay f of a. Now, this function d is continuous na at f of a. Alright? In particular, the limit is still equal to 0 kasi nga ang kukunan mo lang ng limit essentially ay si v of y. Now, malapit na tayo makarating dun sa magiging condition, dun sa magiging gamit nitong mga definition na to. Pero first, we'll note that g of y minus g of f of a ay equal to this guy. Well, para lang siyang yung si d, okay? Tapos ang ginawa ko lang, ito ay tinranspose ko. So nagkaroon ako ng g prime of f of a plus d of y. So this should have been a plus. Nakalimutan ko pa siyang i-edit. Okay. Tapos mag-multiply ako both sides by y minus f of a. So ayun, y minus f of a. So indeed, ito na lang yung natira. Why did I insist that this should be the right hand to be the left hand side? Kasi ito yung nandun sa, or ito yung malapit yung itsura dun sa numerator ng G circle F. The only difference is that now, iba yung variable. Ang variable ko dito ay y. Ang variable ko dito sort of ay f of x. So what I can do is I can take y be equal to f of x. So ito ay magiging g of f of x minus g of f of a all over x minus a. Tapos lahat ng y's dito, papalitan ko lamang ng f of x. Actually, dalawa lang naman yon. Ito yung y dati, ito y din yan dati. But I just changed the variable. I let y equal to f of x. Tapos ito na, kukunan ko na lang ito ng limit. Because essentially, ito si g prime. Ito si g circle f prime of a. So pag nakunan ko siya ng limit, gusto ko, alam ko na mag-exist yung limit na yon. Alright? So kailangan kong ipakita na yung limit nito as x approaches a ay nag-exist. But that's fine because g prime of a is a constant insofar as the variable x is concerned. So ang limit nito ay sarili niya. Limit ni d of f of x as x approaches a. Pero kapag si x approaches a, so this approaches d of f of a. Pero ano ba si d of f of a? D of f of a is equal to 0. So limit nito ay 0. So natira na lamang si g prime of f of a dun sa first factor. Tapos kukunin natin yung limit nito as x approaches a, but that is essentially f prime of a. And that is this guy. This exists because f is differentiable at a by assumption. This also exists because g is differentiable at f of a. So we're done. Okay. So ito na yung, we know that this exists. Actually, na-establish din natin yung quotient rule, yung chain rule. Okay. So that ends the proof. Medyo mahaba lang, tas komplikado yung dinaanan, no, si V at saka si Y. But I hope this is straightforward. All right. Mukhang medyo marami na yun. Sige, last na to. Tapusin na natin itong distraction natin for today. So, if there are no questions with the chain rule, tingnan natin itong interior extremum theorem. Medyo binigyan siya ng pangalan, pero ito ay yung result na ginagamit yun na sa Math 36. Ito yung necessary condition para sa relative extrema. Sabi natin dati sa optimization sa Math 36, ang candidates para magbigay ng relative maximum o relative minimum ay yung mga points kung saan 0 yung first derivative. Yun yung naging basis natin dun sa ating optimization technique na pag nakuha mo na yung function model, kunin mo na yung derivative niya, equate mo kay 0, makukuha mo yung possible sources of relative maxima or minima. Okay? Ngayon, formally, ipoprove na natin siya. Ang sabi ng interior extremum theorem, kapag daw si f ay differentiable sa isang open interval, And then if we assume that f attains either a maximum or a minimum at the number x sub 0 on that interval, then ang derivative dapat ni f kay x sub 0 ay equal kay 0. So kaya siya necessary condition. Kapag ka si f ay merong relative extrema or relative extremum kay x sub 0, it is necessary that the derivative is equal to 0 at that x sub 0. Okay, yung proof medyo ano lang, madali lang naman yung proof. Medyo ano lang, constructive nga lang siya ng konti. Pero hindi natin kailangang i-construct explicitly yung mga gagamitin natin ditong objects. Because for instance, if we will let x sub 0 to be the number kung saan nag-exist yung isang maximum or isang minimum, okay? So nandun siya sa interval AB, then we can construct, dahil nasa open interval siya, kaya kong mag-construct ng dalawang sequences. Una, sequence ng xn's. Pangalawa, sequence ng mga yn's. Now, what's the requirement? Ano yung gusto kong mangyari dito sa mga sequences na to? Gusto ko si xn nagko-converge papunta kay x sub 0 pero mula sa kaliwa. Tapos si yn nagko-converge papunta kay x sub 0 pero mula sa kanan. Yung sinasabi ng inequality na to. And I can really do this, or I can construct such an xn and yn, kasi nga si x sub 0 ay nasa loob ng isang open interval. Tapos lahat ng elements ng isang open interval ay parehas left limit point at saka right limit point at the same time. So because that happens, then we will have the following. Kasi limit point si x sub 0, left limit point siya. So ibig sabihin, maraming elements yung open interval na nagkukumpul-kumpulan sa kaliwa ni x sub 0. So kaya pwede ko siyang gawin. Ganun din siya dahil nandun siya sa loob ng open interval, makakakuha ko ng sequence mula sa kanan niya na magko-converge papunta sa kanya. Yun yung kung bakit kaya ko tong i-construct. Yung condition, or pwede ko tong i-impose dun sa construction ni xn at saka ni yn. Okay, so let's keep that aside. Ang importante rito ay i-assume ko na si f ay maximum, si f of x sub 0 ay maximum value. Kung minimum value si f of x sub 0, then you can adopt the similar arguments, right? Medyo babaliktad lang yung ilang inequalities, but the transition will be straightforward. So gawin ko lang yung pagka-maximum si f of x sub 0. Kapag ka si f of x sub 0 ay maximum, siya yung pinakamalaking function value sa buong interval. So ibig sabihin ng f of xn minus f of x sub 0 ay laging non-positive. Tapos yung f of yn minus f of x sub 0, dahil nga si f of x sub 0 ay maximum, etong difference na to ay laging non-positive. Okay? So ngayon titingnan ko, okay, so ano yung itsura ng derivative? Kasi gusto nating ipakita na yung derivative ay equal kay 0. Ano yung itsura ng derivative? Well, tingnan natin. The derivative must exist, right? Kasi sabi natin, assumption si f ay differentiable. So si f prime x sub 0 as a limit must exist. Tapos, dahil nag-exist yung limit by the sequential criterion, dahil meron tayong dalawang sequences na parehas nagko-converge kay x sub 0, dapat yung sequence of function values nila ay convergent din to the same values. Otherwise, magiging non-existent yung limit. Okay? So tingnan natin. So dapat ito raw ay mag-exist. Tapos, by the characterization theorem na binanggit ko kanina, dapat ito rin yung limit ng f of xn minus f of x sub 0 over x sub n minus x sub 0. So pwede mo itong tingnan, ito yung function na kino-consider natin dun sa pagbuo ng sequence. So ito yung function for the new sequence. Pag nag-plug in ako dyan ng x equals x sub n, dapat magiging convergent yung function values. So yung f of xn minus f of x sub 0 minus xn minus x sub 0 will converge. Tapos equal yon dun sa f prime of x sub 0. But we can note here that by our assumption kanina, this guy is always non-positive, right? Kasi nga, ayun. Kasi nga maximum si f of x sub 0. So this is non-positive. The denominator is also non-positive. Kasi nga, yung mga xn nanggagaling sa kaliwa ni x sub 0, so this cannot be positive. So here we have a non-positive divided by a non-positive, so we will get a non-negative answer. Okay, so that means f prime of x sub 0 is at least 0. Now, if we will use f of yn, same arguments, f of x sub 0 equals sa limit na to, nag-exist yung limit na to, so dapat yun din yung limit nitong sequence na ito. Okay, so yung sequence ng f of yn minus f of x sub 0 over this should have been y sub n minus x sub 0. Pero tingnan natin yung numerator at denominator. Yung numerator ay non-positive pa rin kasi nga maximum yung f of x sub 0. So this guy cannot be positive. The denominator, on the other hand, is non-negative. Kasi nga yung mga y-n's nanggagaling sa kanan ni x sub 0. So this guy must be greater than or equal to 0. Now we're taking the limit of the quotient between a non-positive and a non-negative number. So that means the quotient, the limit should be non-positive by the order limit theorems. Okay. Pero medyo we are on dangerous grounds here because we already mentioned that f prime of x sub 0 must be greater than or equal to 0. And now we're saying that f prime of x sub 0 is also less than or equal to 0 at the same time. So to avoid any contradiction, these two statements can only be reconciled and should be reconciled by concluding na isa lang naman yung common value na pwede nilang i-take, and that is f prime of x sub 0 equals 0. Okay? So yun yung nagsasabi na, okay, pag ikaw ay merong relative extrema, dapat yung derivative mo laging 0. Or in other words, kapag ka nandun ka sa pinakatuktok ng graph, ibig sabihin dapat yung slope ng dapat yung tangent line ay horizontal. Ganun din kung nasa ilalim ka, nasa pinakailalim na point ka na ng graph, yung tangent line ay horizontal pa rin. All right? And I think we can stop here. Actually, naka more than half na pala tayo ng pages. 6 out of 10 pages na. So on Thursday, we'll continue on with Lemma 4.1 and look at, I think, 3 or 4 major theorems. Meron tayong Darbow's theorem for the derivative, which is basically, ano lang naman to? Version ng intermediate value theorem para sa derivatives. And then meron tayong Rolle's theorem. Tapos mean value theorem. Tapos may isa pa, generalized mean value theorem. And a couple of corollaries in between. But let's see if we can finish it on Thursday. Pero feeling ko kaya naman siyang tapusin sa Thursday. Kasi nga kailangan natin magtrabaho para ma-distract. So, and then on Tuesday, next week, we can start with the last unit. Para by the end of May, or even earlier, we can have the third problem set, the third and the last problem set. But I'll be fine if i-move natin yung deadline ng problem set number 3 papunta sa first day na ng finals week para medyo magkaroon na kayo ng mas konting time. Pero tingnan natin kung ilang days yung kailangan natin para matapos yung unit 5. Kasi there's also value to doing the last problem set earlier than the last week of classes para hindi siya sumabay dun sa mga problem sets sa ibang courses. So let's see. Tingnan na lang natin kung ano yung schedule na mag-work best for you. Okay? So other concerns, final questions regarding what we did today or about the problem set? Okay, so if there are none, I really appreciate you, Anna, joining me today. Have a good afternoon, have a good night, and then let's see each other again on Thursday, especially hopefully with more attendees, okay?
Thank you, sir.
All right, bye.